It's mostly going to be a Q&A session with Anton. Anton has been a DevOps engineer, a platform, like working in the field of platform engineering and DevOps for more than 20 years right now.
Yeah,
Right.
20 years.
Yeah, and I've been always fascinated with the platform engineering team, how they handle things. Like starting from my first day at Crux, where I was not able to set up Vagrant properly. And I had like 3 people coming to my laptop and like helping me out. And like I found like this is really cool. There is so much to be done over here just to set up a Vagrant and things to get my local development environment get started.
Indeed.
I think there's still a problem, but let's not go into that right now.
That's true.
So I've been introduced to Anton back at Crux, and I have been dabbling with like infrastructure and platform engineering starting 2019. And thanks to Anton for helping me out. To learn the best practices and tools. And I think this will be a good opportunity for everyone to learn those best practices that I have learned from Anton. So let's start with some history.
History, hey?
History day, yep. So basically, infrastructure has evolved a lot. Given that I am learning and I'm able to do infrastructure work, that says it all, right?
Yeah. You'll always be the intern, Aaron.
Yeah.
You'll always be the platform engineering intern.
So how would you say infrastructure tools has evolved, or what were the challenges which were there back at Crux, which you weren't able to face at Catch, and with the help of tools, you were able to solve it?
Yeah, so back at Crux, we had a lot of, it was a Python shop, essentially. So we had a lot of automated tools written in Python that would go and interact with the Amazon API and spin up an EC2 instance. Mind you, this was all manually. You issue a command, a platform engineer would issue a command to actually go and do that. And once that happened, you'd have a bootstrap for Puppet. Who's used Puppet? Don't raise your hand, Peter. Okay. So what basically happens is that you spin up this EC2 instance, it gets bootstrapped, and it takes ages to bring things up. And if it's a brand new service, that's going to be at least 2 to 3 weeks before you could actually write all your Puppet manifests and get a static cluster up and running. So it was time consuming. Automation is key. So at Catch, I chose to use all CNCF tools, essentially. I love my sleep, as I mentioned yesterday. I don't want to get woken up for an EC2 instance that's died in the middle of the night. Who cares? But back at Crux, we had to get paid for that because a cluster was a static cluster serving one service, for example, might have 10 machines in it. If 1 or 2 machines went away, that was a service degradation, and would someone have to come along and run that Python script to actually bring it back up again? We didn't have anything like Terraform back then. We were using essentially custom-written Python scripts to do all those things. I'd also forgotten about Vagrant. That was fun. So now at Catch we use Terraform for everything. Don't want to manually change anything in the AWS infrastructure. At Catch we have, and I'll talk about this a little bit later as well, but we have isolation for all our environments in different AWS accounts to ensure that there's no accidental, oops, I thought I was in prod, but I was dev, and vice versa, and mistakes ensue. So being able to actually provision infrastructure in a predictable manner is key to doing that. So if I want to bring up a UAT environment, I want to make sure it's exactly the same as everything else. So those are the patterns that we've employed at Catch, and it allows us to be much more agile. Things self-heal. It's awesome compared to Crux. I don't want to say anything bad about Crux, but it's a lot better at Catch.
Nice. So you mentioned about the infrastructure bits. How would you compare the application deployment and those things where you have multiple services and the service discovery bits? How hard it was to do it on EC2 machines directly versus using a container orchestration platform like Kubernetes?
Yeah, I mean, back at Crux, the service were basically pets. Like you'd have 1 machine out of a cluster of 10, which was the master or the main instance that controlled other things. And if it died, well, there was no self-healing. So there was a lot of that. There was a lot of 1 machine is exhibiting some weird scenario, or someone had come along and done a security update on all of them and missed another one, so that it would be weird inconsistencies. And so that was a real pain point. And sometimes it might take days or weeks to even realize that there's an issue on that 1 machine out of the entire cluster. So that was quite challenging. We used a lot of Debian packages back then because they were just EC2 instances running Ubuntu. So we'd bundle our software up in Ubuntu Debian packages and release them that way. But we also had a lot of Python, so we had PyPy repos, and there was always inconsistencies because of custom scripts and things like that. So now at Catch, and obviously if we're using Kubernetes, we use Docker for everything, so it's extremely predictable. So it's been an interesting journey going from those those technologies to an automated CNCF sort of style infrastructure.
Cool. So moving on, I know this is more about infrastructure best practices, right? But I think infrastructure and applications go hand in hand. There is, when you're thinking of application development, how should we think about it? And where does well-architected come into play in this kind of a situation?
This is actually quite important for startups because I'll talk about well-architected infrastructure in a sec. There's 6 different pillars that we try to align with. But for startups, it's all about forward thinking around how things are going to fail. As you can see here, these are the 6 main areas: operational excellence, security, viability, and so forth. They all everyone knows them. They kind of make sense. But how do you actually implement them? What tools do you use? But this is what I would consider the things to be looking at when creating new services, creating new infrastructure. So let's dive into it.
Sure. So let's look into operation excellence. So for application developers, would you recommend something to keep in mind while they're designing their workloads or they're architecting their systems so that it's helpful to get metrics out of it, to understand how this application is performing, or even just to get the state of the application?
Absolutely.
Yeah.
I love metrics. One of my personal passions is performance tuning, and without metrics, I can't do any of that, right? So I'm sure everyone here has been in a situation where you've trying to investigate a problem, and it's like, wouldn't it be great if I had that metric that could tell me more details about the thing that I think is broken? You always go into these service development or software development thinking that what are the metrics that may be useful for us in the future to determine scale, determine problems. These are the things that you should do right from the get-go. More metrics, the better. I just keep on saying to guys in my company, it's like, more metrics, I need more, even though Prometheus is struggling. But anyway, I'll get to that later. But and I think there was a talk yesterday about OpenTelemetry. Using that will allow you to get a huge amount of capabilities for metrics straight off the bat. And using other open source tools, like you can see the icons here, like Prometheus, Grafana, you can use all those to actually visualize that and do alerting and so forth, which I'll talk about later as well. But basically, right from the beginning, think about metrics. It's usually one of the last things that people usually do, but it's so important.
Is it like for desserts? I like desserts, so it's like if it's sweet, it's good, but not too sweet. So is it something like for metrics where too much metrics is not good?
Yeah, that was another thing that came up yesterday. High cardinality is an issue, usually because it requires additional resources inside a time series database. And the longer you retain metrics for, particularly in Prometheus's case, you end up requiring a significantly more amount of memory for that because they're usually in-memory databases. There are other tools to actually work around that, but high cardinality is one of the big killers. So try and keep that limited.
Cool. Let's see what else we have. So in a particular system that works, in production things, we see there is defects. How can we easily detect them? Maybe remediate them quickly? Or how can we improve the flow into production, the deployments? So how should we think about these things, to remediate defects as well as to improve the flow in production?
Yeah, it's like I was saying before about back at Crux, you have all these little special snowflake instances that did a particular thing and the others didn't. That's a bad idea, right? Someone engineers coming along and SSHing in and making a change and it doesn't actually make its way to Puppet or what other tool you're using, it becomes extremely problematic. So using GitHub and Gitflow to effectively define infrastructure as code. And you can do that via different ways. You can use Terraform, you can use Ansible. I don't particularly like Ansible, but anyway.
Ansible fine, sorry.
So at Catch we use Terraform, we're heavy Helm users. So that's the way we deploy all our code on our services on Kubernetes. So it's extremely predictable. So the key takeaway is just don't do anything manually. Make sure it's all committed in Git and usually use the usual change control process to get things rolled out. I kind of covered config management there as well. So as far as build pipelines, I mean, we use GitHub Actions. We use Flux. We have used Circle CI in the past, but those are the sort of tools that you always want to do. You want to release rapidly. You don't want to have to run a manual deploy script or make a Puppet change and wait for it to actually get rolled out in an hour's time. That's just terrible. You want to be quite agile. So make sure you use tools like GitHub, GitLab, all those sort of things.
Any reasons to switch from Circle CI to GitHub Actions?
So for us, we moved from Circle CI to GitHub Actions because we've got a lot of repos in GitHub, and it made sense for us to actually tie those all together. So we made a move to GitHub's container registry as well as GitHub Actions at the same time. We were previously using Docker Hub, but it has some funny issues.
But again, with GitHub, right, you're using so many services. Does it mean that you're putting all eggs in one basket?
Yes, it is. But we also use things like Artifactory as well. So we can actually clone or make mirrors of our other repos to actually distribute those and cache those as well. So, but that is a good point. All our eggs are in that one basket. But we made a conscious decision around that based on the reliability of Circle CI at that particular time. That was a few years back. And the roadmap of GitHub Actions and the other GitHub products. So it was a good trade-off.
Cool. So this is kind of important to me. Like, I always think that health is something whether the application is up and running or not. But how do you typically determine the health of a workload, of an application, of a service where it's up and running? Is that the only thing that we want to know? Or is there additional things which would help us identify whether the service is working as expected or not?
Yeah, absolutely. If anyone's used Kubernetes, you know that you've got liveness checks and they're basically checks like a /healthy or something like that. Now, that could just be a OK or a 200 or not, and that just basically kills a pod. But that's really useless, really. You want to know about the request rate of your application, the latency. Latency is a big one. You want to know that if something down the stack is actually starting to degrade its performance. So you want to know exactly where that is. So latency is a big one that I would always ensure that was in all services. Your company might have cyclic behavior. So I know back at Crux, we had quite a big peak, but then as people turned off their laptops and desktops, that nighttime traffic profile dropped a lot. And we had a lot of wasted resources for that. But we knew that at a particular time of day, actually there's 2 times in a day, morning, a little bit at lunch, and then as everyone was leaving and obviously visiting other websites. So we had a very predictable pattern around our workload. So we could actually use that to base our autoscaling groups and preload our autoscaling groups to basically ensure that we had enough capacity to soak up that traffic. So those are some things that I would look at.
Okay, cool. So that was interesting about operation excellence. Do you want to talk about the next pillar? Are you ready?
Security.
Security, the best thing for you. And Peter, where he was not giving me access at Salesforce at all. So this is interesting. Like, with all these new tools that are available to manage your identities and to have dynamic identities and dynamic secrets and stuff. So how would you say to manage people identities and access to developers to production instances or developer instances for debugging purposes, and versus machine-to-machine communication?
So this is actually interesting. How many of your companies have done SOC 2?
Yeah.
So all these things, all these pillars associated directly with things like SOC 2, right? This one's an obvious one, but basically, you don't want to silly things like you don't want to share usernames and passwords and things like that. Everyone has to have their own unique login. You have to have things like MFA. These should be standard things for everyone, but you just got to talk about it, because sometimes there are certain things where you think, oh, maybe it's just a username password, it'll be fine. You don't have to worry about MFA, but it's extremely important for your business to protect. Like the weakest link to any company is through the human, right? So if your password is leaked online and you don't have MFA, you are going to get bots hitting your service, and at some point you are going to get compromised. And once an attacker comes in, they just move laterally, and it's really easy for them to do that. So you want to protect that login as much as you can. We use Auth0, and we enforce MFA on all our services. I quite like Authy as the authenticator.
You moved from Salesforce Authenticator?
Yeah. The Salesforce Authenticator was actually pretty good because it was tied to my phone number, but it was kind of janky. I like Authy, so you can actually run that across multiple different devices, like your laptop, your phone, so things like that. So it's pretty decent. In regards to authentication for services, short-lived tokens is ideal. You can use things like HashiCorp Vault to go and connect to a database as an administrative user and dynamically create users passwords for your service accounts, for your developers. There are lots of automations around that, so that is something that you really should investigate if you're starting to run some new databases.
Cool. So moving on, how do you protect the compute resources, because there's a lot of crypto mining happening? They might use your AWS account.
So
Just saying.
I was saying before about using Docker containers, and usually you go build them and they've got all the CVEs updated and patched, whatever, but you've still got your EKS or your Kubernetes workers, which still need to be patched. You have to have a good strategy for patching, essentially. What we do at Catch is that our Kubernetes workers only last for a total of 30 days. And then they just get shot and they get replaced through the Autoscaling group. And that ensures that as the new workers are coming up, they all get their security updates, and that happens automatically. We don't have to have someone logging in and go, oh, is this CVE patched? Yes, no, I'm not sure what to do here. So that's our strategy. We also use spot instances for almost all of our EKS workers, so that ensures that they're always cycling through. But that's pretty important, patching everything.
Yeah, so when I was using Terraform back at Habu, I used to get these Terraform plan changes whenever there was an AMI upgrade, right? Mm-hmm. Is there something that those were mainly for the self-managed nodes? So would you recommend now using something else so that these patches are already taken care of? And if you don't have a proper infrastructure team, and if you want to focus your resources towards application development, so what would they tend to use at that time?
Well, that's actually a good strategy. And what I was just talking about there is in the Terraform code, there's some regex that basically selected the most recent AMI that Amazon had released for EKS in this particular case. And you have like a cron job that runs, so you have a Terraform plan run once a week or once a day or whatever, and when there's a change, you can just go and apply it. Do it in dev first before prod, but that helps you actually maintain that latest update. So that's still a really good strategy.
Okay, cool. Is there anything that we can use, like manage node groups and Fargate?
You can.
Okay.
I prefer to use EKS over Fargate because I like the flexibility of EKS. But yes, you can use any of those tools to achieve that.
Cool. Nice.
But the point at the end there, we don't SSH to any of our servers. We don't even have SSH accounts, right? And so that forces us to take action from remotely, right? So through IAC or the Helm charts, you should never have to SSH to a machine, ever.
Cool. Nice to know. So how do you protect your data in transit? Like there is a lot of I'm involved in working with Headlamp, which has healthcare data, right? So how should I think of it, like when I'm handling these data and then data is moving across services?
So you should always be thinking about zero trust. I heard I missed the microservices talk yesterday, but I know a lot of people terminate TLS at the gateway or at the front end and consider their traffic inside their VPC to be secure. Sure, it's secure. But what if one of your services were compromised? And if you're running Kubernetes or something and somehow they gain root, they can run TCP dump and be able to sniff that traffic. And so if you're not using MTLS, then it's there for the taking. So you should always look into using MTLS between your microservices. Again, zero trust. Don't trust anything even on your internal network. You can use things like HashiCorp has a product to help encrypt transit as well, dynamically. There's other tools like Istio. Istio allows you to do MTLS really easy if you haven't already got it. It adds a sidecar and allows you to control what microservice talks to what microservice, and it's encrypted, which is great. But yeah, I would highly, highly recommend using MTLS between your services.
Nice.
Obviously, use certificate managers. Amazon Guard Duty is actually really cool. It just sits in the background and just scans your CloudTrail logs and looks for abnormalities. So it's as Peter will say. Every now and again, we get an alert for a weird IAM access from India, right? Because it detects abnormalities, right? So most of our engineers are in the US, but we've got a team in India. So every now and again, it's like, oh, this is a weird request. It's an authenticated request, but it's just abnormal. And it pops up and gives us an alarm. So it's really good for detecting those sort of things, which you may not actually even be looking at or looking for.
Yeah, even at Habu, I saw it, like when Simran is from Canada, right? So when she was accessing, like, oh, this, like, oh no, this is cool. This is a trusted user.
And it'll dynamically adapt to your workflow as well. So it's great for the normality checks.
Nice, cool. So moving on to the next pillar, reliability. Do you want to like elaborate a little bit, like what does reliability mean in context of a well-architected review process?
It should be pretty straightforward how reliable the service is. Think of what I was saying before about losing an instance and it actually degrading your cluster. You don't want to go into those design patterns where you're in that situation. So reliability is really around the availability of your services and the ability to recover from outages. I remember a few projects ago, I was doing real-time bidding for display advertising. So we had like 80 millisecond SLAs, including network transit time. And so that was a tough SLA. But we encountered a whole bunch of different things, like someone had dragged a backhoe through their sidewalk and took out fiber optic line. And that caused a significant latency increase to that particular region. There was another incident where a boat had dragged an anchor through a submerged cable. And so therefore, I think this was to the East Coast. And so basically traffic, the way the internet works is obviously if there's degradation, it reroutes around. And so that had happened, but that caused our latency to significantly increase. So we needed to have a strategy to ensure that we weren't as impacted by these events, and they happen quite a lot, much more than people realize, to ensure that our service remained reliable and we're able to be within our SLAs and provide a response within the 80 milliseconds, right? So it's just interesting the different types of failures that can happen. So you need to factor all that in when you're building your services or your companies.
Is that the reason that a couple of times the office Wi-Fi is degraded because somebody's drilling a hole?
Probably someone torrenting or something like that.
So, like, how should we, as developers, think about designing workloads, or even as infrastructure engineer, platform engineers, think about auto-scaling with changes in demand, right? You mentioned something about Crux, where like the traffic pattern was like there was peaks in the daytime, whereas not in the nighttime. So how to avoid wastage and all these things.
Yeah, so that's right. So back at Crux, that low traffic period was quite low, but the high traffic period was substantial. But the time in between, because it wasn't using auto-scaling groups and they were static workloads, we were just basically burning money as the resources weren't being used. So take into consideration that. Think of the resources that you'll save, the money you'll save just from auto-scaling, but also if you have a predictable pattern like that, where you have like high traffic periods during the day and low of nighttime, like I said before, you can preload your ASGs to ensure that you have that traffic. Another good example there is for things like DynamoDB. If you're using DynamoDB, you need to change your reads and write rates before it happens. Otherwise, you'll get rate limited. So that's one scenario where that's significantly more important as opposed to EC2.
Mm-hmm. Cool. So in regards to that, like, we have a lot of data, right? This client data and stuff. How do we think about backups? And like there are different use cases, like you said, DynamoDB. I think Ketch is also using Scylla.
Yep.
Yeah. Which is the permit store, right? Mm-hmm. And then there is other databases like MongoDB and other places, right? How should we think about? Should we rely on the snapshots from the cloud providers, or can we leverage some other external services for other SaaS things?
So this is a it depends answer. If you've had a chat with me at all over the last couple of days, I've always
I got a lot of that.
My first response is it depends. It really does depend on what it is you're actually doing. Obviously, if you're saving in some kind of a state, yes, back that up. But it also depends on what that data is required for your business, right? So and what risk profile you have. If it's just throwaway data, snapshot, sure. Do you even need to do a snapshot? Costs money. Maybe doesn't need it. In most cases, you do. And there's a lot of different mechanisms to do backups. It might be a boring subject, but AWS Backups is actually a pretty cool tool. So you just add a label to the resources that you want to back up, like an EBS volume, and it just happens in the background. It does mean, though, that if you needed to restore that data, it's the whole snapshot. So if you needed to restore a certain component or a certain table, I'd take a different strategies. Like if you've got an RDS instance and you want to back up a particular table or a database that's more important than others, you could probably do that through like cron jobs or through Kubernetes kube jobs. So that would be the way to achieve that. But again, it's basically on the risk profile of your application in the business.
So I know that this is a SOC 2 requirement where you have to have backups for your data, right?
Yes, absolutely.
And there are cost implications too. So as a startup, should we bear those costs, and what will be the right sweet spot for us to have the backups? Like, what would be the retention of the backups? What was the frequency of the backups?
It depends.
See.
Again, it's based on the risk profile, right? So if you're, let's just say you're creating a database table and it's just perhaps throwaway data, and then you're just replacing that, or dropping the table, replacing that table or that database, then it doesn't make sense to retain the backups for long periods if it's just throwaway data. Like things with RDS backups is 35 days, I think it is the maximum retention period. Otherwise, if you need it to be kept longer, then you have to have another strategy, and that's where something like MySQL dumps or Postgres dumps would be ideal.
Mm-hmm. Cool, thank you. How to use fault isolation to protect your workloads?
I touched on that briefly before around, we have different AWS accounts. So I have like a master payer account, which sole job is just AWS organizations. And I have another account, which is just IAM users, another one dedicated to prod, another one for security, another one for storage, and the list goes on. So basically, you want to make sure that you have good trust boundaries between your different environments for starters. But even in those environments, AZs will fail. There's been plenty of times where we've lost like US East 1 and maybe US West 2, AZB or whatever it is. So you want to ensure that you have your workload distributed across multiple failure domains. In case of AWS, it would be availability zones. If you have latency-centric services, that you need to ensure that the requests are, the latency is as small as possible to your users, you might have to actually spread that across 2 different regions. So it depends. What I do personally is I usually choose 3 availability zones, so that way I know that if we do lose an availability zone, we still have enough capacity in the other 2 without having to endure major ASG increases and things like that, and potentially hitting Amazon limits, because there are limits as to how many instances you can run in certain regions, right? So those are the things that I would be ensuring that a infrastructure or a new infrastructure would have off the bat.
This would have cost implications too, again, right? Like if you have 120 microservices multiplied by 3, it's a lot of machines which is running and a lot of cost. Would you consider that as an operating cost, or is it something that can be reduced?
It's the same as the backup question as well, right? Yes, it's an operating cost, but it's not a significant amount of machines. If you only need 10 machines in that particular cluster, you just spread them out over those 2 or 3 AZs. So you don't have to have the same amount in each of those AZs. Well, it depends on the service. Like Scilla, for example, I need multiple racks, and there has to be the same amount of machines in each AZ. But generally speaking, it can just spread. And that's what I love about Kubernetes as well. Like if you lose an AZ, all the pods just move around, and so that's great. The caveat though is the cross AZ network charges. You do get charged for that, so just be aware of that. So if you've got really chatty services, Cassandra is kind of like a little bit of a one, because it has to replicate to different AZs, or racks as they call it. So you just need to take that into consideration. I think we talk about costs later, so I can go into more into that.
Yeah. So this is interesting, like for startups, how do we think about disaster recovery? Like most of the times you're using cloud services, and you rely on the cloud. Okay, like if anything happens, it's a managed service, things will be taken care of. So do we really need to think about disaster recovery?
Yeah.
Really?
Who has a DR site? No one.
Even Catch? We're not talking about it.
So it is important, and particularly for SOC 2. Most people don't think about DR really until something goes wrong, and then we usually scramble to try and get things back up again. So this is a scenario where you need to determine what the failure domains are and what the impact of the business is, and particularly how long it's going to take for you to bring all that infrastructure and the services back up again. For Catch, we have a pretty complex environment. We've got over 2,500 pods running in any given region. There's like several hundred machines. There's lots of database servers. There's a lot of Scilla clusters. So it is hard for us to actually maintain an active DR site because it's not cost effectively right now. But there's other strategies though. You can actually do things like have an EKS cluster over in a different region, but just scale everything to 0. And in the event of a DR, or in a DR event, you would just basically go and you can have this programmatically done as well. You can just scale them up to whatever the required size are. So that's a great strategy to use. But please don't forget about DR, because the last thing you want is to have everything go down in US East 1 or whatever the problematic zones are, and then scramble for the next 3 days trying to get all your stuff back up and running again. And this is also why IAC is so important. So I can just say Terraform, apply, boom, everything's there.
Nice, thank you. So let's talk about performance efficiency. I think this is where I think you will redirect half of the questions to me, and I don't get to answer the questions. So how do you select your compute solution? What are the things to keep in mind?
Through the SDLC process, you should be doing things like determining the capacity of a service, like how fast can it go until it starts degrading. You should have a good understanding of the performance characteristics of your services. And that service may require a certain amount of memory, a certain amount of CPU. So you should be determining that right from the beginning. A lot of people will just create a deployment in Kubernetes and just leave the limits and resource, the requests and limits for resources for memory and CPU as just nothing. And then all of a sudden we get some CPU throttling issues and whatnot. So you should define exactly what resources you need, how distributed that application needs to be across EC2 instances, and that will usually guide you on how large your Kubernetes workers should be.
Is there any rule of thumb of using spot instances versus on-demand instances versus serverless?
I like to use Spot for my EKS workers because everything should be self-healing. There should be no state. So pods will just move across the cluster. There are certain scenarios, in my case, I've got RIs, reserved instances for my Scilla clusters because they are a little bit more sensitive to cluster topology changes. So again, it depends, but you get a huge cost benefit for using Spot instances. And really, you should be architecting your services for failure. I love Netflix's chaos methodologies, and that's what I expect. I expect things to fail because shit does fail. Yeah. And you want it to self-heal. And again, I like my sleep.
Nice. So you spoke about compute. Now, how about databases?
I don't know. What do you think?
Well, I think it depends. Definitely. It depends on what type of application it is, and like whether you need a document store or a key value store. If you're looking into some kind of a cache, or let's say you have you can use regular RDS, right, which is a relational database, right? So I have mostly used Postgres relational database, MySQL, and MongoDB, and DynamoDB to some extent. But yeah, apart from that, I haven't that much experiences with databases.
But also use the right tool for the job. Just because database is like the latest hotness doesn't mean you should be using it. So first determine that first, and then go look at what are the technologies that are most useful. Like AWS in particular for their Aurora service is actually pretty nice. It's a little bit expensive, but it does a great job. Otherwise, you can run that stuff yourself.
So one thing that comes up while using databases and managing databases is, I'm not a DBA, but how will I use, what kind of tools can I use to understand my database performance? I faced this challenge at Stanza while working with the MongoDB cluster, and we ended up using a managed service. What could have been doing better to monitor these kind of databases and keeping an eye on certain metrics of how the database is performing?
Excuse me. A lot of different databases have different ways of monitoring their performance. Oracle has its own special Snowflake way. Mongo has another. Scylla and Cassandra it's entirely different. There are a lot of, like if anyone's using Prometheus, there's a lot of Prometheus exporters that can actually connect to those data sources and pull out useful metrics, and Prometheus automatically scrapes them in. So that would probably be the best approach. The best generic approach. Otherwise, you could use the different tools available by those database technologies. Like if you're using MongoDB, what is it, Atlas? They provide some good metrics there as well. But of course, if you're running MongoDB yourself, then you would need to have something figuring out what those useful metrics are and then exposing them to your monitoring system.
So is slow queries a good metric to keep track of?
Yep.
Or number of inserts and things, writes and reads?
Yeah. I mean, latency is always a big one. Determining when there's locks. If you're using something like MySQL and doing bin log replication, then make sure that there's no lag for that. So that's a big one. But it really depends on the database and what you're actually doing, whether it's distributed, if it has a single main controller and the rest are all slaves, or it's a little bit different depending on the actual tool.
Cool. So, now we spoke about adding metrics to our applications, right? Mm-hmm. But now let's talk about performance, right? How do you identify whether that service is performing really well or not? Or how can we as application developers think about it in a better way so that we can enhance our application performance? I know one of them comes to my mind is latency, like you mentioned. Yep. If there's an SLA, what other things that you think will be there?
Latency is the big one for me, but also just error rates. Like how many times are you actually throwing 400s or 500s? So you can use things like a Prometheus's alert manager to specify when alerts go out when they hit a certain threshold. So for us at Catch, we have a blanket set of alert manager rules that says if the error rate is higher than 5% of the traffic coming in, then fire an alert. I don't care if there's this one, well, I do care, but I don't care as much if there's one 503 here and a 404 there, but if it's greater than a certain percentage, then I know something big is going on and I need to know about it. So definitely look at things like that. You know your own business, so you know what's important for your business. So those are the things you should think about when you're actually developing an application to ensure that you have enough metrics that you can visualize, but also more importantly to alert on when things go wrong. Like if you've got sales, for example, and the sales drop off to nothing, it's like, okay, it didn't increase that to a certain threshold, so make sure that you have a baseline that you know if it drops below a certain point, tell someone who cares. So those are the things that you should really be thinking about. But it's really, you know your business, so you know what the business logic is, so take that into consideration. And just always remember, if you're investigating a problem in a year's time or whenever it is, be helpful to future you and create the metrics that matter right from the beginning.
Cool. Nice. So we tend to use a couple of trade-offs, right, so that we can improve performance. So how do you think about those trade-offs? And should we even do it?
Yeah, so we do it at Catch for a couple of things, particularly around caching. Caching is a good one. So to avoid stampeding herds, for example, where we have a huge amount of requests coming in and obliterating the performance of the databases, we do a lot of caching. We use Fastly for a lot of our JavaScript, and the trade-off there is that obviously if it's going into a cache, then it stays in that cache unchanged for a certain period of time before it gets evicted and so forth. So when you make a change to the system, it may not actually make it to the public until whatever that time frame is for that object to expire. Like it might be 20 minutes, it might be forever. So again, it's latency related as well, right? So if you're relying on these objects to be available fast, then caching is probably not the right idea. You need to find out some other way to scale that out to improve performance. But if you find that you can actually do things like cache it for a certain period of time that alleviates the workload on the back end, you get a fast response rate from the cache, and that's a good situation for your customers. But again, it's a trade-off. So you've got to figure that out from your business to determine what is that good value.
Okay. Nice. So this is the best topic. This is where we save money and we can use it for our boost budget. So let's talk about it. So how do you monitor usage and costs?
where'd you get these numbers from? They're quite low. So usage and costs. So back at Crux, we were using Cloud Health Tech to monitor our costs. It's a great service. I approached them when we created a catch, and it was like, I think it was like $5,000 a month for that service. And at the time, I think our AWS bill was like $4,000. So it didn't make sense. Now it's a different story. But I used a lot of the AWS tools to determine abnormalities and project what my costs are going to be. You see from these example graphs here, I can see like the purple ones on the right-hand side there. I can see that it's fairly static, but something's changed between those. So you can dive in and figure out which service is now causing an increase in costs. And for us, we had a situation where, again, it was Scylla. It was very I/O heavy, and so we had an increase in costs for EBS storage. And I was able to visualize that here in these tools and drill down to figure out what the actual cause was. It's great for forecasting your costs. It's great for seeing where the most cost is going in regards to different environments. So what I was saying before about splitting up our accounts, I can see exactly how much the total bill is from the master payer account, but I could also see it individually, like this is how much dev's costing us, and this is how much prod's costing us. So it's very insightful. So you should be looking at tools that allow you to determine your costs and forecast. And AWS actually provides a fairly decent window into that.
So you mentioned about Cloud Health, right? And you were looking into that, but then you found all the metrics and everything available in AWS itself. Is there anything that you feel is lacking that you would like to have in a tool that you haven't found yet? Or you have found the tool and you just don't have the time to kind of implement it?
Yeah, so when it comes down to, S3 is not too bad now. They've added some features where you can actually define exactly where the cost is going instead of just a high level, this is how much S3 costs. But having things like labels and tags on your resources, so you can actually separate that. This portal doesn't really do a good job of that, but then so that would be something I would really like, and particularly with Kubernetes is an interesting one, which is not solved here. Whereas, let's just say, for example, we're running 2,500 pods. Where is the major cost driver from that? Now, I actually know it's Scylla because I actually dived into that, but I don't know really how much individual services are costing. There are tools that allow you to get some kind of a view of that, but it's not complete, and that'd be something that would be really cool to have.
Nice. So let's say you're selecting a new service. Now, I think you definitely did that by selecting Scylla, right, over DynamoDB. Like, what were the analysis that you did? Or is there any research or pricing estimate that you performed to achieve that particular end conclusion of choosing Scylla?
Yeah, so we have a good example for that. When we created our permit store, we didn't have a good solution to store. That's just a key value store, essentially, was what we needed. And in those early days, it made sense for us to just fire up DynamoDB because it's there. We could use it pretty efficiently. But it costs a lot, right? So we did analysis on the cost and what effort would be involved in moving to an alternative. And so one of the other things as well is that all the architecture, all the infrastructure that we use is all mostly CNCF. So I didn't want to be locked into an Amazon service. So for like our customers, for example, might be running in GCP or Azure, and I wanted the ability to actually run our stuff in those environments, and that's why I chose CNCF tools to allow that portability. And of course, if we're using DynamoDB, can't do that. So we knew going into that it would be fast getting DynamoDB up and running. It would serve our purpose pretty well, and that at some point would actually move away. And we had chosen ScyllaDB to perform that function. So at a certain point where the cost of DynamoDB, there was a break-even point, right? So we got to that point, and we started the migration off of DynamoDB onto Scylla, and that's the way that we approached that. So if you're thinking from a startup perspective, you may not have all the resources to go and create these databases or these different technologies, you should look into the cloud providers' services if it makes sense, but always keep in the back of your mind, what would it take to actually run that yourself, and to just to avoid lock-in. I remember back at Crux, what was it? We were so into AWS. I think was it Walmart as a customer, and they're like, Walmart's, we don't want to pay a vendor that's paying our competitor. So we looked at what it would take to actually split out onto GCP, and it was not cost effective at the time. So just keep that in the back of your mind. How easy would it be to move to a different cloud provider if you needed to?
Cool. Now, I think you touched upon this a little bit, but then what are the things that we can do from an infrastructure perspective? Or what are the steps that we can take to reduce our data transfer cost? I think that's kind of a major component of the AWS bill.
Yeah, that's right. So hopefully no one's got classic AWS accounts anymore. I don't think they exist. But in your VPC, if you're doing a lot of like S3 workloads, like EMR, any kind of MapReduce or whatever, to get out of your VPC and retrieve the S3 objects, that incurs a significant cost, right? Because you're actually doing the data transfer, and particularly through the multiple AZs. So one of the big things to do there is to have the S3 endpoint inside your VPC, so all that is free traffic. So that'd be like a major one that everyone should be looking into. And there's endpoints for DynamoDB, for S3, KMS, exactly. So you want to avoid egressing your gateway, essentially, or your NAT gateways.
Even for VPC peerings?
For VPC peering, what was the scenario that you're thinking there?
So like you have two different EKS clusters in two different regions.
Okay.
So would you recommend VPC peering over going through the internet?
VPC peering is much better. In regards to peering, just be prepared to have different CIDRs or different subnets, because otherwise you're going to get a collision and you won't be able to route to that peered VPC. But in that scenario as well, you do pay for that transit. So just keep that transit to a minimum.
Okay. So this is about sustainability. So I don't even know what it means. Can you help me understand?
Sure. It kind of goes towards what I was describing before at Crux and what we've done doing at Catch, is where we have the wasted resources, right? So you don't want to be in a situation where you're paying for a fleet of EC2 instances when they're not actually being used. And that's one of the beauties of using Kubernetes, is that your workloads will dynamically move around the cluster where there's available resources. The sustainability thing is essentially don't waste your compute. For starters, you're paying for it, and you don't want to be paying for it, and it's just better for the environment, right? Don't run things that you don't need to.
Cool. So I was wondering if there is any tool available that you can use to achieve the well-architected process. Is there any platform or any software or service that you can think of is available in the market that we can use?
For all the pillars, there's a lot for individual pillars, but Amazon actually do have a well-architected documentation page, and in your AWS account, you can actually go through a questionnaire that asks you questions around all these topics, and you answer them truthfully, I hope. And it will give you the risk assessments for each of those things and where you should actually be focusing on. I should have put a link to that here, but check it out. In your Amazon account, you'll see that.
Cool. So there is a shameless plug over here, guys. This is about Capstan. It's a no-code, low-code tool for your cloud infrastructure provisioning and operations. It will help you automate your cloud infrastructure provisioning. It will also deploy and scale your applications, monitor your applications and infrastructure using this tool. Security, the compliance. All these things are following the best practices to deploy your infrastructure, as well as integrate with your external applications like MongoDB, Datadog, Vault, and even GitLab. So it should be available soon. Any questions? Oh, I asked a lot of questions then.
Yeah, you did.
Yeah, sure.
That was great, Anton. We do get asked a lot by customers that how do you define your RPO, RTO? What is your disaster recovery plan, right? How soon can you get your stack up? What is your recovery time objective? What is your recovery point objective? Mm-hmm. So how do you think about that? And then so what advice do you can you provide to startups that
Yeah, so part of SOC 2, you have to have done a disaster recovery. It'd be a planned one. Now, for us at Catch, we do a tabletop exercise. So we go through all the steps that are required to actually bring everything up in a different region. And then we look at how long that takes. So we know, for example, to spin up an RDS instance, it's going to be like 20 minutes, right? Or even longer. Even an EKS cluster, how long does that take these days? Around about
15, 16 minutes.
Yeah. So you got to take that into consideration. Then you also look at what is the impact to the customer. So you could have a degraded service and still be able to respond to your customer in a suitable time frame, and you could work behind the scenes to recover everything else and make it highly available. But what is that amount of time that it's going to take to get to that point? And that would be something you should definitely be thinking about. And you have to look at your SLAs in your contracts as well. They should align. So if you've got an MSA that says the service needs to be recovered within 2 hours, it needs to be back in 2 hours. Otherwise, you're going to have penalties. It really depends, again, on the business and what those objectives are. But doing a tabletop exercise is a good way to start that process.
Anton, thank you so much. So much depth in all of this presentation. I just had a question on, you spoke about a lot of different topics, having, cost optimization, performance. Are there any one or two things that you would point out as where is this infrastructure, the products that manage and maintain and set up that infrastructure, where is that industry going? Are there any trends? Is ISC one of the top trends? Anything that you kind of project for the trend in this industry or where it's going over the next 1 or 2 years?
So IIC is getting really popular now. You want to ensure that you can bring up predictable environments, right? Like I was saying before, if you bring up a region and it's slightly different, you don't want to have to go through that pain, and that will actually ruin your SLOs for your recovery. So IIC is one of the big ones. Automate as much as you can and do that through Kubernetes and Helm charts and through Terraform. I think that's a fundamental part that will go towards achieving that.
Great, thank you.
I have one.
Uh-oh.
So, yesterday you mentioned one of the technologies that you wish you had a decade ago was Kubernetes.
Yeah.
Do you have a wish list right
Of
now?
all the things I
No, just let's do one.
a wish list for past me?
Yeah, for what would you like now, but it's not just available right now?
What do I like now? Tough question. I don't know. I'm also one of those people that will just try to solve things through automation and whatnot. If I knew that product, I'd probably be building it. And but it's hard of an answer. I guess the top of mind problems at the moment, I'm dealing with some Scylla consistency issues around the multiple rings and performance related stuff. So getting more insight into that and being able to automatically remediate stuff. So I'm super interested. Where is Tyler? Checking out Robuster and actually using tools like that to help remediate certain predictable issues like that. That'd be something that's I'm really interested in right now.
Thanks.
All right. Anyone else? All right. Thanks.
It depends.
Thank you, guys.